Welcome to the University of Maryland at College Park. I'm Ben Shneiderman, and we at the Human-Computer Interaction Laboratory have been studying users of bibliographic systems, information retrieval systems, and database management systems for many years. In these studies, we've identified one of the major areas of difficulty that novice and experienced users have to cope with, and that is the use of boolean queries. Our users found problems not only in making typographic errors, but they also were confused in the operator precedence in Boolean expressions and the use of nested parens. In addition, we found many users were confused about the meaning of the and, the or, and the not operators. This stems in part because of the confusion with the intuitive meanings in English. In English, and is meant to expand a set, while in Boolean queries, the addition of an and operator will restrict a set. In English, the use of the word or is meant for mutual exclusion in most cases, whereas in Boolean queries, the use of the or will expand a set. During the past year, we've come up with a new way of representing Boolean queries that we think is potentially an advantage for many users. Daisy Young has implemented this filter flow method using the Toolbook software application from Asymmetrics Corporation.
The graphical filter flow representation was designed to provide users with an interface that conveys the meaning of the Boolean queries. This was accomplished in two ways. The first way uses a filter flow metaphor. The second uses a graphical approach. The filter flow metaphor allows novice users to transfer meaning from a known domain, water flowing through a filter, to a new domain, the operation of the Boolean queries. The graphical approach provides visual feedback to the users, so users are sure that the query they formed was the query that they intended to form. Imagine that there is a massive amount of water passing through a filter. As water passes through the filter, some of it is held back. The more filters you have, the more restriction you have, and the less amount of water is allowed to pass through. The same thing happens when you use a graphical filter flow representation to form an intersection. The initial employees are placed over here, and the attribute title, location, manager, salary, title are placed above. Users may create the screen by dragging the attribute menus to different locations of the screen. Let's say I want to form the query, list all the Californian drivers. I choose the attribute title location and choose the value California. I also choose the attribute title and choose the attribute value driver. As the tuples pass through the attribute menu location, only those employees that come from California are allowed to pass through. Of those employees, we're interested in only the drivers, and they're allowed to pass through and land over here. So if an employee is over here, that employee is located in California, and that employee is driver. There are two methods of forming a union operation. The first method is within an attribute menu, so that you can select two values within that attribute menu. The second is using two different attribute menus. For example, let's say I'm interested in finding all the employees that are managed by either Daisy or Janet, or I'm interested in finding the employees who live in Georgia. In this case, it is important to notice that the amount of information that enters this attribute is the same amount of information that enters this attribute. It is possible that an employee is managed by Daisy, and that same employee is located in Georgia. It doesn't matter which route the subject takes, the employee takes, as long as it's from the initial employee to the resulting employee. In specifying the negation operation, users can press this X over here. In this case, all the values that were selected before become unselected, and all the unselected values become selected. Previously, all the employees who were from Georgia were allowed to pass through. Now they are not allowed to pass through. Instead, the employees from Alabama, Bahamas, California, and DC are allowed to pass through. The previous operations and, or, and not can be combined to form more complex queries. An experiment was conducted to compare filter flow with SQL. In the comprehension task, 17 out of 20 subjects made an incorrect query in SQL, while only 4 out of 20 subjects made an incorrect query in filter flow. In the composition task, less than 20 errors were made in filter flow, while 120 errors were made in SQL. Finally, subjects preferred to use filter flow than SQL. Indeed, one subject claimed that she was lost in Bracket City when she used SQL, and that the visual feedback in filter flow helped her to form queries correctly.